Hi students, I'm Praveen Sebastian Paul. In this lecture, we are discussing the floating point representation of a decimal fraction number, or it is also known as IEEE 754 representation. So before going to discuss, let us consider a floating point decimal number. Let us consider the number 12.625. For converting a decimal fraction into a binary representation, so as we all know, the number 12, the whole number part 12 can be converted like, so continuously divide 12 by 2. 12 by 2 will result in 6 with a remainder of 0. When 6 is divided by 2, it will result in 3 with a remainder of 0. When 3 is divided by 2, that will result in 1 with a remainder of 1. So that is, the decimal number 12 is equivalent to the binary number 0.625. 0.625 can be represented in binary as multiplying this 0.625 with 2. That results in 0.625 into 2 will gives 1.25. And for the answer part, we are taking this 1 to the answer part, and the rest portion, that is 0.25, is again multiplied by 2. So 0.25 will result in 0.5. This 0 is taken to the answer part, and the rest portion, that is rest is 0.5, that is 0.5, is again multiplied with 2 will result in 1.0. So this 1 is taken to the answer portion, and 0 is multiplied again with 2, that will result in 0. So the final result is, that is 12.625 can be represented in binary as 1100.101. So this is a simple representation or normal floating point representation or normal binary representation of a decimal fractional number. So in this lecture, we are discussing how to represent this in IEEE 754 format or floating point representation format. So basically, there are two types of IEEE representation or IEEE standards. They are, the first one is single precision standard, and second one is double precision standard. In the single precision standard, we are dealing with a 32-bit representation, and in the case of double precision, we are dealing with 64-bit representation. So there are two types of representation of floating point. They are single precision and double precision. In single precision, we are dealing with 32-bit, and in the double precision, we are dealing with 64-bit. So there are three different portions in this single precision as well as double precision representation. They are, first bit is the first representation is for the sign bit, exponent bit, and third is for the mantissa or the fractional part. In the single precision representation, one bit is for sign bit, and 8 bits are for exponents, and the remaining 23 bits are for the mantissa part. So in the 32-bit representation, 23 bits are for mantissa representation, 8 bits are for exponents, and 1 bit is for sign of that particular number. In the case of 64-bit representation, again we can see 1 bit is for sign, 11 bits are for exponents, and the rest 52 bits are for the mantissa part. So in 32-bit, 1 bit is for sign, 8 bit is for exponent, and 23 bit is for mantissa part. In the case of 64-bit representation, 1 bit is for sign, 11 bits are for exponent, and 52 bits are for the mantissa or the fractional part. So this floating point representation is actually focusing upon the floating point or the mantissa portion representation.